Welcome to another special edition of Daily Airline News. I'm Jeffrey Thomas, and again, of course, we're focusing on the search for MH370. A lot of the questions have come through asking us about how we get the data for tracking Armada 7806, and of course, the data for the Whisper technology that's tracked MH370 to one of the hotspots. Delighted to say once again, I'm joined by UK aerospace engineer and the man who has perfected the Whisper technology, Richard Godfrey. Richard, it's over to you.
So let me take you behind the scenes today and show you where we get this data from. I'm going to share my screen. There we go. So you should now be seeing my screen where I will go into my internet browser and look at Vessel Finder. Vessel Finder is the software I use to track Armada 7806. So this is where Armada 7806 is currently. We can see its previous track. We can see what ports it called in, what the weather's like, and we can show the speed currently that it's progressing at. And if you zoom in, you can see Armada 7806 has been tracking backwards and forwards across the MH370 search area. It's currently at the southern end. The hotspot from the IG is up here at the top. And the next hotspot is down here from Captain Patrick Blely and Jean-Luc Marchand. And the basic trend is they're working their way southwestwards towards the Blely Marchand hotspot. Tomorrow, we expect tomorrow evening that Armada 7806 will head off towards Fremantle, and we can follow its progress there. Another thing we do each day is take a look at the weather. So go into Zoom Earth and position the excuse me, position the cursor at around 35 degrees south and 93 degrees east. So that's around where Armada 7806 is currently. The wind is from the west at 16 kilometers an hour. There's this cyclone Bianca up here, but that's quite a long way away. There's a couple of cyclones over here, Garance and Hondo, but that's even further away. And then this sort of system down here with very high winds, 66 kilometers an hour. But again, that's a long way south. And the trajectory from the search area across to Perth is looking good for the transit to Fremantle. So that's Zoom Earth. And now I'm going to show you how we track with the Whisper data. The software I use is called MATLAB, and I have a number of processes which I will run through. But let's have a start by looking at Flight Radar 24. Flight Radar 24 is one of those apps like Flight Aware and others that show you all the aircraft that are currently in the air anywhere around the globe. So there's quite a concentration over America, over Europe, Middle East, down through to Asia. But you can see in the Atlantic Ocean and the Indian Ocean and the Pacific Ocean, very few aircraft. In fact, when MH370 went across the Indian Ocean, there was no ADS-B data because the transponder was switched off at the point of diversion. But we can check here with the statistics. So there are 12,271 aircraft being tracked currently, and they're tracked by different means, but the majority are tracked using ADS-B data, 9,000 currently. There are a few with so-called space-based ADS-B data that is via satellite. The regular ADS-B data is land-based receivers. And with an app like Flight Radar 24, you can actually go back in time. So go back, say, to my birthday on the 1st of August last year and have a look what was happening at that point. So a similar number of aircraft, a few more, 16,000. And we can pick any aircraft we want. This is a flight from Delta Airlines from Cape Town to Atlanta. Quite an interesting one because it's being diverted to San Juan. And we can find out what type of aircraft it is, the registration, what altitude, the track, the ground speed. It's currently being tracked in the flight information region from Luanda in Angola. It has a unique code with the ICAO. And finally, we get its latitude and longitude. So that's a lonely aircraft in the middle of the Indian Ocean. And we can actually go and find the data for that aircraft in the ADS-B database. And then we can find out exactly what it's doing and where it is flying. So we use ADS-B data to compare with the WSPR data when we run a test. So, for example, we go into the ADS-B data, ADS-B exchange. We pick a date like the 1st of August 2023, and we go into the individual JSON files. There's a file for every aircraft, and when you look at it, it gives you the location, and this one I picked was on the ground, but it then will at some point here it is it'll take off, and so you get the latitude and longitude, and you get the altitude and the speed and so on. So you get a detailed recording every few seconds of where that aircraft is. So what I do is first of all I have a look at that ADS-B data, and then I will have a track through that to find the aircraft I'm interested in for the particular test. As you can see, this is the list of JSON files on the 1st of August 2023. There are in total 73,540 aircraft that were in the air at some point during that 24-hour period. And I can get a list of those aircraft. So I can, the first one's actually a balloon and an Embraer 135, and so on. And I go down the list um, and I'm in the picking out the Boeing 777. Here, for example, is a Boeing 777. PHBFK is the registration. It was tracked in ADSB data with 35,000 or 36,000 entries, and it has the ICA code 485000. And in my database, it's index 84. So what we do is, first of all, I run a process to get those whisper time, the ADSB data at the whisper points in time. So here we are, my index number 84, and I'll let that process run. And what this process does is looks at the ADSB exchange data and downloads that. It then analyzes the data and it produces two output files. The first output file gives me all of the data from ADSB for that aircraft on that day. And the second file gives me the ADSB data, but at the whisper points in time, each 2 minutes. So whisper runs for 110.6 seconds in a transmission, and there it is. It's finished, so we can now have a look at that data. And so here it is. I get the time, the latitude, longitude, altitude, ground speed, track, and rate of climb, and I can cut and paste that into my system. This is usually done automatically, but just to show you what's going on, I can do it manually, and I can then set up a file for today's demo and cut and paste that in. So here we are. I've got my data, and this is synchronized with the whisper time. So whisper time 0034 and 1 second, with 2041 seconds past midnight. Whisper starts every even minute and 1 second past every even minute and lasts for 110.6 seconds. So here I know the aircraft was at this latitude and longitude at the start of this time frame, and at this latitude and longitude at the end of the 110.6 seconds. So that data can be fed into my whisper process. So this is how the whisper process works. I've called this test case 999, just a number. We can check when the aircraft is present or when it's not present. It's interesting to see what whisper signals there are when an aircraft is not there and when it is there. And we're looking at this date and time on the 1st of August 2023 at 34 minutes past midnight. These were the positions transferred from the start to the end of the 110.6 seconds. And we're going to check for anomalies over a plus minus 3 hour period from this time 0034. So we let that run, and this goes into the whisper database. I'm having a problem with a timeout here, so I'll just let it run again. It looks at the Whisper Live database and pulls out the data. I'm told it has more than 5,000 rows, and it only lets you take 5,000 at a time. So I just run another small process here, which is completed, and there are in total 5,446 rows of WSPR data at that particular point in time globally. The next process I run is to add the call signs from an antenna database to the WSPR data. The WSPR transmitter and receiver locations are only approximate in the WSPR database, but we have built an antenna database which has the precise location of each of these transmitter and receivers. So that's run and now tells us that all of these 5,446 WSPR transmitters and receivers, the call sign has been added and there aren't any missing in the database. And then the heart of the process is tracking the target aircraft, and we're looking within 40 kilometers or 40,000 meters of the supposed position of this aircraft according to ADS-B, and we're tracking 1,200 points around the globe. We use a spherical Earth reference for the WSPR transmissions, and we use a WGS-84 Earth reference for the aircraft path. The Earth is not a perfect sphere; it's a little bit squashed, but there is a subtle difference in using a spherical Earth for the radio transmissions and a WGS-84 reference for aircraft, and this process run through and checks the great circles and comes back and tells us there are 229 aircraft within 40 kilometers of 229 WSPR links within 40 kilometers of the aircraft. The next process is to check the anomalies, and we're looking at these 229 WSPR links that come close to the aircraft. 40 kilometers is the maximum range an aircraft can travel when it's doing, say, 630 knots. And this is checking now to find all of the links which have at least 5 rows of data within plus minus 3 hour time frame. And this is again checking for each of these 229 on the WSPR Live database, and that is now finished and tells us there are 207 out of the 209 which are useful for our purpose. And finally, we look at all of those 207, which are now within a range of 50 meters of the aircraft, and bearing in mind a Boeing 777 is of the order of magnitude of 50 meters long, 50 meters wingspan. And we're looking here much more precisely with 10,000 track points on a great circle path of each WSPR link around the globe. So we let that process run, and it produces at the end an output file which gives us all of those anomalous and non-anomalous links. So that's completed and tells us within 50 meters of the aircraft there were 6 anomalous links, in other words, a true positive, and 1 non-anomalous, in other words, a false negative, and the sensitivity of that test was 85.7%. So we can take a look at those links that were picked up by that process. There were these six. This tells us that the first one was call sign AK1WI, and the receiver was DJ6DK. These are the call signs. The frequency band used was 7, and there were 35 rows of data in the plus minus 3 hour time frame. And the aircraft was obviously present. The signal noise ratio anomaly was 95%. Here it's 189, the frequency anomaly 94. So we take those and feed them into the WSPR mapping process, just to be able to visualize what's going on. Here are those links in the mapping process, and we let that run. And it then shows us this is where the aircraft is at the start of the 110.6 second WSPR transmission. This is where it is at the end. And these are the WSPR links that cross that path during that time frame. It's probably easier if I take a regional map, a little wider view. So this is the top of Nova Scotia. This is Prince Edward Island. That's Newfoundland. And that's where our aircraft is. We can also take a global view of that map. The aircraft is here. And these are all the transmitters marked in black and the receivers marked in magenta, which are the links that we have used in order to track this aircraft. And finally, we can produce a route map from the ADS-B data and the WSPR data. So this flight was from JFK to Amsterdam. And this is where it currently is in the tests we just run. These black dots are where we have ADS-B data. So there are two parts, one over America, one over UK, Ireland. And in between over the Atlantic, there is no ADS-B data, but we have then the WSPR tracking for the aircraft during that time. And we have done now literally thousands of flights in all parts of the globe. So MH370 took off in Kuala Lumpur and was going to fly to Beijing, but it didn't. It diverted back over the Malacca Strait and down into the Indian Ocean. And we've been able to track with the WSPR data the whole of that flight. So that's essentially how the WSPR software works, and I'm sure you will have a few questions, but you can send in any questions you might have and on the comments, and we will do our best to answer them.
Thank you very much, Richard. That was a pretty amazing demonstration. It's probably got a lot of people searching for their calculators to try and sort of work it all out. But look, it's a staggering piece of technology that you've harnessed and developed more software around that to process it all. And I'm certainly sure you've answered a lot of questions, and a lot of folks would be thinking, "Wow, this is technology really at work," and has a lot of possibilities, not only for tracking MH370, but a lot of other possibilities for tracking aircraft all over the world. So thank you very much indeed for your time on this one. And as Richard said, please send your questions in after this demonstration. We'll try and answer them. Well, I won't, but Richard will in a forthcoming episode. But please subscribe to us, please like us, and please do leave those comments. We really do appreciate them. And please tune in tomorrow for another update on the search for MH370. Thank you.
Thank you.